Under the topic electrochemistry, we've got these electrochemical cell, galvanic cell, Nernst equation, conductance of electrolytic solutions, electrolytic cells and electrolysis. Then we have batteries. Then we'll be discussing about fuel cells and corrosion. I think I already completed the conductance part of it. Is it not? I completed conductance part of it. Then I wanted to discuss about, I already explained about electrolytic cells and electrolysis, that is Faraday's law. And in today's class I will be explaining about the batteries, electrochemical cells and Nernst equation. Okay, and what are the difference between the electrolytic cell and electrochemical cell, right? Okay. Now, consider this voltaic cell versus electrolytic cell. Make a note of it. Voltaic cell can also be called a galvanic cell or electrochemical cell. And electrolytic cell, that is based on the electrolyte. Actually, there are some differences between this electrochemical cell and the electrolytic cell. Electrochemical cell, here the chemical energy is converted into electrical energy. Whereas in the case of electrolytic cell, electrical energy is converted into chemical energy. Then delta G is minus, that is negative value. It means, what is delta G? Free energy change. What is free energy? Available form of energy according to thermodynamic definition. Gives the free energy. Available form of energy. For example, assume that you had to break an egg, for which you need not use a hammer. You know very well, simply by hitting the egg on the table, you can easily break it. Okay, so you know very well that there is some amount of energy to be used, but sometimes we cannot exactly calculate. Sometimes we will be overdoing the work also. So what is the exactly available form of energy? Probably that is, you would have spent some more energy also. We should not consider the net energy, the total gross energy. So the available form of energy, it means there is some non-available form of energy also. So that is not properly used for the work to be carried out. So this happens in the case of any chemical reaction. So for any chemical reaction, first of all, delta G should be minus, that is negative. So there is an decrease in free energy, and that indicates the genuineness of the reaction, that is spontaneity of the reaction. So spontaneity means what? Natural outflow. For example, when you want to talk to your friend, you can talk freely, naturally. But in front of an audience, you have to prepare your lecture notes, and based on that, you have to give your lecture. Okay, so for efficient speakers, it will be a natural outflow, spontaneous flow. Okay, so when the process is taking place naturally, then it's called spontaneous reaction. And how this spontaneity is interpreted in terms of free energy or Gibbs free energy, it can be interpreted in two ways. One is decrease in free energy, another is increase in entropy. Please make note of it according to thermodynamics. So according to thermodynamics, there is an increase of entropy, but we are not talking about entropy here. So here it indicates the decrease in free energy as far as voltaic cell is concerned. So it means it is a redox reaction, first of all, because we already discussed that in voltaic cell, chemical energy is converted into electrical energy. And here the spontaneity of redox reactions, the key point. So delta G is equal to minus, whereas in this case delta G is equal to, that is positive. It means this redox reaction under electrolytic cell, it is not spontaneous. This is non-spontaneous. It means what? We had to trigger the reaction by charging the cell. So here it requires, that is, we need to charge the cell, and that is why the charging is required. Charging means what? That is, we have to apply current here, okay, for certain time. Q is the charge. Q is equal to charge, that we have already discussed under Faraday's law. So charge is equal to, that is Q is equal to I into T. What is this I? The current that is given in ampere. T, time in second. So 1 ampere second is equal to 1 coulomb. Please make a note of it. So Q is equal to IT. So Q, what is the unit of Q? That is charge in coulomb. So 1 coulomb is equal to 1 ampere second. Now let me proceed further. So in this case, voltaic versus electrolytic cells. Here, electrolytes are kept in 2 different baths. Let me consider. Here I have got one bath. A beaker, you can take a beaker. And another beaker is taken. Now I have to dip one electrode here and another electrode here, right? And these two can be connected like this, okay? Suppose if it is anode and this is called anolyte, okay? If it is cathode and the electrolyte present here is called catholyte. So this is anolyte, this is catholyte. That is, electrolyte is, what is electrolyte? Any chemical or any acid or base or salt in molten form or in solution form that can be conducting current. That is very important. And so these two are almost, that is, separate. It has to be connected using a salt bridge. What is salt bridge? It is a PA type, Tamil letter PA, So PA type tube where we take potassium chloride and that is duly dissolved in agar-agar solution in hot condition. So it becomes gel so that it can be transferred here, and that acts as the what? Salt bridge here. Okay. So an electrode, for example, let me consider zinc dipped in zinc sulfate solution, okay, aqueous solution, and this represents the what? Salt bridge. And here you can introduce copper sulfate solution, aqueous solution of certain concentration, and versus here copper electrode. By convention, we always take anode on the left side, cathode on the right side. And you should never forget that anode acts as what? An oxidizing pole. At anode, oxidation takes place. That is removal of electron. Whereas at cathode, reduction takes place. So what is reduction? Addition of electron, right? Now, let me go ahead. So electrolytes are kept in 2 baths, whereas in the case of electrolytic cell, you have got only one bath where both electrodes are kept and it is available in one beaker. Do you understand this? And the salt bridge, as I already mentioned, if it is present, if the electrolyte is present in 2 different baths, this is called electrolytic bath or some beakers, okay? So, or 2 containers. If the electrolytes are kept in 2 different containers, it has to be properly bridged, and that is why we introduce salt bridge. And this part type tube where agar-agar KCl is kept is called salt bridge, okay, right? So whereas there is no salt bridge introduced here, after all we have got only one bath, a single bath where both electrodes are dipped. And then electrodes are of different material in the case of what? That is electrochemical cell or voltaic cell or galvanic cell. Whereas in the case of electrolytic cell, they may be of same type also, okay. Then in this case, anode is the negative electrode, whereas cathode is the positive electrode. Whereas in the case of electrolytic cell, anode is a positive electrode and cathode is a negative electrode. Of course, here in both the cases, at anode oxidation occurs, at cathode reduction occurs, okay. So this is regarding the comparative study, that is comparison between voltaic cell or galvanic cell or electrochemical cell versus electrolytic cell, right?